So in the previous class, we have discussed about angular bisectors. So in today's session, we are going to discuss about the same part, problems based on angular bisectors. Then we discuss the concept of pair of planes. Later we discuss about some miscellaneous problems. So there we conclude our discussion over the concept of planes. So please take a note of it. Then we start our today's session. Clear? After noting, please tell. Shall I continue? Right. So the problem is find the equations of the planes bisecting the angles between the planes the first plane is given by (2x minus y plus 2z plus 3 equal to 0), and the second plane is given by 3x minus 2y plus 6z plus 8 equal to 0, and distinguish them. So that was the question. Please take a note of it. Then we'll go with the procedure. Right. So I have given the formula in the previous class in order to find the equations of the planes which bisect the angles. So in order to apply the formula, the first thing we need to observe is whether the given planes of the problem are in such a way that the constant terms have same symbols or not. Is the audio fine now? Right. Thank you. So the first thing is whether the given planes, the constants in them must be of the same sign. Either they must be positive or they both must be negative. If they don't have the same sign, we should rewrite the equations in such a way that the constants have the same sign. So we need to change one of the equation so that constant have the similar sign to the other equation. So there is no need to rewrite the given plane equations here. Now we are going to apply the formula straight away. So 2x minus y plus 2z plus 3 by square root of 4 plus 1 plus 4 equals to plus or minus 3x minus 2y plus 6z plus 8 by square root of 9 plus 4 plus So if you simplify that, this value is 3 and this value is 7, doing cross multiplication, now we use plus sign on the right hand side, bring the values to the left, you will get one plane equation. Similarly, we use minus sign on the right hand side, take the values to the left, and we will get another plane equation. So these two are nothing but our required planes. So I will say if you apply those signs, you are going to get the plane equations as one plane equation 12x minus y minus 4z minus 3. Equal to 0. That is one plane equation. And also you can find other plane equation. So do you accept for that? Right. Now the thing is, since you are going to find the two plane equations here, if you want to distinguish between them, that means the two bisecting planes, one plane bisects acute angle and another plane bisects obtuse angle. So we have to know which plane bisects acute and which plane bisects obtuse. Here we are going to follow two methods. I have given one plane equation here. Can you provide me the other? The other plane equation? Have you computed that? (23x minus 13y plus 32z plus 45 equal to 0). All right. 30x. So 5x minus 5 minus 4z minus 3 you are saying here, right? So these two are correct now, right? Now what happens, I will go with the two procedures. The first one is among the given two planes, I take one. So this is the diagram here. Say this is the first plane pi 1, this is the second plane pi 2. So this is the bisecting plane. So among the given two planes, I will take one. Similarly, among the given obtained planes, I will take one. So for computational convenience, I take this and this. Now, between these two planes, let us calculate the angle. So this is the new plane I got. I am finding the angle between these two. Theta I am calculating. So you please give me cos theta value here. what is the value of cos theta? You know the formula that this is the formula we use to calculate the angle, right? So take the coefficients as a1, b1, c1 and a2, b2, c2. Apply the formula and give me the angle, the cos theta value. So 1 by 2 root 10. You accept it all? So a1, a2 plus b1, b2 plus c1, c2, if you apply, the value is 3. One by root 42 is the value. Yes, not 1 by 2 root 10, right? Now, so if you take the angle substitution, this is theta, you have calculated cos theta, so this is 1, this is root 42. So can you give me this value? Root 41? Agreed? Right. Now, since I know the values, I am going to calculate tan theta here. So from this, tan theta value will be root 41. So is this value greater than 1 or less than 1? Greater than 1. So it means that if I calculate tan theta value, it is greater than 1. It means that, as we know, tan theta is equal to 1 when theta is equal to 45 degrees. So if theta is more than 45, obviously tan theta will be more than 1. Agreed? Yes or no? Yes. So what happens here? I have calculated the angle between the given plane and the new plane. Here tan theta is greater than 1 means here the angle is greater than 45 degrees. We are calculating the bisecting plane means the plane divides the total angle between the given planes into two equal parts. So if half part angle is more than 45, so the total angle between the given planes will be more than 90. Agreed? Are you getting me or not? All of you. Right. So the plane equation, the bisecting plane equation is the obtuse angle bisector. Because whenever two planes intersect, one angle will be acute, another will be obtuse. So this plane equation is obtuse angle bisector, whereas the other one is acute angle bisector. So this is the distinction between these two. Now you can ask one more question in this problem perspective, that it is 5x, right, not 15x. Yeah. I am taking this as obtuse angle, not acute angle bisector, isn't it? I am saying it is obtuse angle bisector. Yeah. So the total angle between them, say theta, for the given planes, pi 1 and pi 2. I don't know about this angle, is it acute or obtuse between the given planes. Now, after finding a bisecting plane, this is my bisecting plane 5x minus y minus 4z minus 3. I am calculating the angle between these two, right? I am calculating the tan theta value. Based on tan theta, I am saying it is acute angle bisector or obtuse angle bisector. How? If tan theta is equal to 1 means theta is equal to 45. So any angle which is bigger than 45 here, that means if the half angle is 45, the total angle will be 90. If the angle here is more than 45, total angle will be more than 90. Because the plane is nothing but bisects the angle here. Right. So after calculating the tan theta, I got the value as root 41, which is greater than 1. So this angle is greater than 45 degrees. Hence the total angle is greater than 90 degrees. That's it. So any other queries from anybody? Right. So after distinguishing the planes, we can say one thing, that always the origin lies on one of the sides of bisecting planes. Either it will be on the acute angle side or obtuse angle side, whatever the case may be. While applying the formula, you consider the plane which is obtained by using the plus sign. Always the plus sign plane gives the bisecting plane which is on the origin side. So among the two planes, can you give which plane is obtained by using the plus sign? 23x or 5x? So origin lies on the bisecting plane 5x minus y minus 4z minus 3 is equal to 0. And yes, just we discovered that this is the obtuse angle bisector. So origin lies on obtuse angle side and the bisecting plane of that side is this one. This is the total discussion over the problem. So any question will be framed as find the bisecting planes, distinguish among them, find the origin lying on which side. These three variations generally we expect on the bisecting planes. Okay, clear now? Any more doubts over this problem to anyone? So I discussed about the one approach. There is another shortcut approach is there. So if you didn't get a confusion, that is more convenient compared to this approach. So I will give the procedure one after the other. The first step here is we make constants having same sign, so either both the constants have same sign, either plus or minus. After that, we find the two planes, the two bisecting planes we will find using the formula. Now, the third step is we calculate the third one is the crucial one. So after making the constants in the given planes as positive, we calculate a1, a2 plus b1, b2 plus c1, c2. If the value is greater than 0, origin lies on the obtuse angle side. If it is less than 0, origin lies on the acute angle side. Now what happens? Always we know that whenever we apply plus sign on the RHS, it always gives origin side bisecting plane. Whenever we apply plus sign, the plane obtained by always bisects the origin side thing. So what happens? There is no need to calculate cos theta, tan theta, etc. So keeping view of these 2 points, immediately we can say which plane bisects acute angle and which plane bisects obtuse angle. So let us go for a random check here. Now see, these two are nothing but given plane equations. We observe that constants are of positive sign. Straight away calculate a1, a2 plus b1, b2 plus c1, c2. So 2, 3, 6 plus 2 plus 12. So the value is nothing but 20. This is greater than 0. Agreed? So origin lies on obtuse angle side. Now I have calculated the two plane equations from the formula. Now I know that while applying plus sign, I got this plane. So this is nothing but origin containing plane. So this is nothing but the obtuse angle bisector. That's it. So this is obtuse angle bisector and this is acute angle bisector. You are done. Clear now? Is it clear to all? That's it. So these two approaches, you can make use of any one of them. That is enough. Either the triangle method or this method. Both are convenient. So this is the maximum model you can expect on the bisecting planes. Now I am going to take the new concept, that is about pair of planes. Can I take now? Do you need any more problem on this? Let us take a small thing. Say this is my first plane. Second thing, this is my second plane. So constants have opposite signs. Now what happens? You are going to change one equation between the two. Suppose I want to change this equation. I will take it as minus x plus y minus z plus 2 equal to 0. So for the application of formula, I will make use of these two planes. I will neglect this. Clear? Right. So any other queries from anybody? I will apply A1, A2 plus B1, B2 plus C1, C2 also for these two planes. Whenever the sign is changed, that plane will be completely removed from the procedure. We take only these two planes into consideration and we will do everything for them. Right. Any other queries from anybody? Thank you. So the next model is pair of planes. So please understand that I have taken two intersecting planes . Now what happens, apart from considering the two plane equations, I will consider the product. So if you multiply each and every term there, you will get a new equation. I will represent the equation as this is my new equation. It is just simply multiplying the two plane equations together. A1x into this total value, B1y this total value, C1z this total value, taking the terms as common. So for those coefficients, I am giving the names as A, B, C, H, F, G, etc., etc. That's it. Now what happens? If you take any point on one of the planes, it will satisfy this equation. Agreed? So we call this equation as joint equation of pair of planes. Joint equation of pair of planes. Now the other thing is, the planes what I have considered are passing through origin. The planes what I have considered are passing through origin. So what happens? They won't contain the constant term there. Hence, if you remove the constant term, then you will get a homogeneous equation. So this part is not there. This is the resultant equation. Clear? Are you getting the idea what I said? Please let me know. Right. Now here, in this context, we are going to face the problems of the type that whenever an equation is given, it is a homogeneous equation of second degree. Each term is having power 2. So whenever a homogeneous equation of degree 2 is given, then from that you are going to determine the planes. That is one model. Second, whenever an equation of this type is given, is it really representing a pair of planes or not? So, will this equation is a product of two planes of this form genuinely or not? So, nothing but verification. Next one is, what is the angle between the two planes? We will calculate cos theta as well as tan theta. Another model is, as I have given a big equation earlier, so combining these two, you will get a big equation here. Whenever a big equation is given to you, so if that big equation gives two parallel planes, find the distance between them. So these are the similar questions we regularly get over this model. Okay. I repeat, the first thing is, here onwards we take the joint equation of pair of planes. Joint equation is nothing but, I have taken two plane equations. If I multiply them together, I will get a big equation. If you take the homogeneous part, this is the homogeneous part, each term having 2 degree. So, whenever an equation of that type is given, I should verify that whether it is an exact product of two planes or not. For that, what is the verified conditions? That is one. Second, since it is giving two planes, so apart from finding the planes, straight away I am calculating cos theta as well as tan theta. So here I am not finding the planes, I am straight away calculating cos theta and tan theta. And we can say one more thing, that are they parallel or perpendicular? And what are the direction ratios also we are going to discuss. If you take the non-homogeneous equation, if that equation represents two parallel planes, what is the distance between them and how to find the distance? This is the total summary of this context. Clear to everyone? Say. Right. Now, suppose you consider the homogeneous equation where each term having second degree. So the verification part is, we calculate the determinant AHG, HBF, GFC, this equal to 0. We use the symbol delta for this one. AHG, HBF and GFC. So the determinant must be equal to 0. That was the first case. And second, these three conditions together must be satisfied. So if these conditions are satisfied by that homogeneous equation, immediately we can say that it satisfies the given condition, so it represents a pair of planes passing through origin. and the formula for cos theta is given by a plus b plus c whole divided by, so square root of so this was the formula. Please take a note of it. So a plus b plus c whole square plus 4 into f square plus g square plus h square minus ab minus bc minus ca. Now obviously what happens, cos theta value may be negative or positive depending upon acute or obtuse angle model. So in the numerator we take the value as positive, so we should take modulus in the numerator. So modulus is optional there. So we consider the angle in the positive sense. Okay? Clear now? Have you noted the formula? Right. Then the formula for calculating tan theta is nothing but 2 into square root of f square plus g square plus h square minus ab minus bc minus ca whole divided by a plus b plus c. This is the formula used to calculate tan theta. And one interesting thing is, since the homogeneous equation is giving us two planes, they may be parallel, sometimes they may be perpendicular. So the checking condition for is they will be perpendicular if a plus b plus c is equal to 0, and they are parallel, or you can call them as coincident if f square is equal to bc, g square is equal to ac, and h square is equal to ab. So please take a note of these values. And observe that the big equation is obtained by the intersection of the two planes. There is no need to know the derivations. If you are interested, I will give the picture. You can take a note of them in the WhatsApp group or Telegram group, which is given there. Right? If you are interested, I will provide them. You can check for it. Very easy to understand. Much discussion is not at all needed. So the thing I want to mention here is the homogeneous equation or the other big equation which is given there. Say it is nothing but the equation obtained from the intersecting planes. So as we know, the intersection of two planes is nothing but a line. So the drs of that line is given by square root of f square minus bc, g square minus ac, and h square minus ab. These are the direction ratios of that line of intersection. Right? You take a note of that. So in order to visualize the thing, so this is one plane and this is other plane. So you will get a line of intersection here. For this line of intersection, these are the direction ratios. If you multiply the two plane equations together, you will get a homogeneous big equation which is given earlier. Apart from calculating these two plane equations, by observing the homogeneous equation, we can say whether they are parallel or perpendicular. You can calculate the direction ratios, you can calculate the angle, and you can verify whether the equation is a genuine equation or not. Fine. So if you are clear about the concept, I will give the problem. I will ask you to solve right now so that we have a discussion. So this is the problem I want to take. 2x square minus 6y square minus 12z square plus 18yz plus 2zx plus xy. This is the homogeneous equation I gave to you. Now, you have to check whether it represents a pair of planes or not. If so, calculate the angle. So angle is always by default we are calculating the cos theta, right? So first of all, let us compare the equation with ax square plus by square plus cz square plus 2hxy plus 2fyz plus 2zx. So from that you can say a is equal to 2, b is equal to minus 6, c is equal to minus 12, and if we calculate fgh, f is equal to 9, h is equal to 1 by 2, g is equal to 1. So do you accept for those values? Now I request you to calculate the determinant which I have given to you and tell me whether it is 0 or not. And secondly, please verify the conditions that h square greater than ab, g square greater than ac, and f square greater than bc. Then only it represents a pair of planes. And after applying cos theta, give me the angle value. I will say the value of cos theta will be 16 by 21. Please understand, I arrived at that value by using modulus in the numerator. So it may be positive or negative. I am always taking the positive value in the numerator. So cos theta value will be 16 by 21. You please go ahead. Take your time. And give me your reply, because one problem is enough for this concept. Much practice is not at all required. It is only formula based question. One more thing is, apart from calculating the determinant, if you expand the determinant, the formula what I have given, the expansion of the determinant is nothing but ABC plus 2FGH minus AF square minus BG square minus CH square. So if you know the values straight away, you can substitute here and check whether this value is 0 or not. So determinant, substitution, calculating that is one thing, or the expansion of that is nothing but this formula. You substitute the values here and check whether it is 0 or not. Both the ways are correct. So if everyone is clear with the problem, can I take the other one? So I will take the consent from everyone, then only I will start. So you got the angle also, 16 by 21, cos theta value, right? Now I will take the other model. I just want to write one equation to get an idea. So please take a note of this equation, and obviously you know how to calculate the debt and how to verify the three inequalities. So you can say that it represents a pair of planes. If at all it is asked, describe about their nature. So if you observe the coefficient for the squares, 6, 4, minus 10, nothing but the values of ABC. So if you add them, the result is nothing but 0. So immediately you can say that the two planes are nothing but perpendicular. Similarly, I have given one more checking condition, whether they are coincident or not. So from the observation of plane equation, immediately you can say about the nature of the planes. Right. Clear to all? Okay. Now let us take the other context. So this is the equation I want to write. So x square plus 4y square plus 9z square minus 12yz minus 6zx plus 4xy plus 5x minus 10y. So plus 5x plus 10y minus 15z plus 6 equal to 0. So this is the equation I considered. Alright. Now the question tag of the problem is, suppose this big equation represents two parallel planes, then find the distance between them. So did you get the context? All of you? Right. Now, for this you have two approaches available. One approach, first of all we take the homogeneous part here. Now I observe that, is it possible to write this thing as square of something? So my interest is, can I write it as x plus 2y minus 3z whole square? So that expansion will come, because since the term z is presented, you are having negative symbol. When z is not there, you are having plus symbol in that homogeneous part. So for the homogeneous part, that is the expansion. Now understand that this entire thing is nothing but product of two planes. So since it is representing parallel planes, obviously x, y, z coefficients are same, you will have a constant. X, Y, Z coefficients are same, you will have a constant. So the non-homogeneous part is obtained in this equation by means of the additional constant terms here. So this whole thing I will write it as x plus 2y minus 3z plus k some constant dot x plus 2y minus 3z plus L. So this whole big equation is nothing but product of these two. Clear? Any doubts for anybody? Let me know. Right. Yeah. The thing is, from the question, it is saying that this total equation is representing two parallel planes. Accepted? Right. So, how the parallel planes will come? If you talk about parallel planes, they will contain x, y, z terms are same, only constants will differ. So, in this big equation, I have taken the homogeneous part first. So, from that homogeneous part, I deducted that it is equivalent to this square. So, what happens? The non-homogeneous part is a result of including the constant term here. So, how the parallel planes will come? X plus 2y minus 3z plus some constant, x plus 2y minus 3z plus some constant. If you multiply these two planes together, then this total thing is nothing but the homogeneous part plus this extra thing. Okay? Right. So, now I compare these two things here. Actually, we need to multiply the entire thing. On observation, there is no need to multiply. We simply compare what is x coefficient, what is y coefficient, what is z coefficient, what is constant from here. So, constant will come only when you multiply these two things. So, KL is equal to 6. And coefficient of x will come. So, if you multiply kx as well as lx, so k plus L of x is nothing but 5x. So, k plus L is nothing but 5. If you go for y, it is nothing but 2k plus 2L of y is equal to 10y. Clear? So, you are going to get the value as k plus L is equal to 5, KL is equal to 6. Now, what happens? You have a formula that k minus L whole square is equal to k plus L whole square minus 4KL. Substituting the value here, k minus L whole square, you will get the respective value there. So, you have k plus L is equal to 5, k minus L is equal to 1. You can solve that. 2k is equal to 6, therefore k is equal to 3, therefore L is equal to 2. So, the respective planes are nothing but x plus 2y minus 3z plus 3 is one plane, x plus 2y minus 3z plus 2 is another plane. These are nothing but the constants. So, in this model, we will get the parallel planes as well. So, if we calculate the distance between them, it is simply modulus of 3 minus 2 by square root of 1 whole square plus 2 whole square plus minus 3 whole square. As you have a formula, modulus of d1 minus d2 by square root of a square plus b square plus c square, which gives the distance between the two parallel planes. So this is one method of doing them. Okay. So 1 by root 14 is the answer for distance between the parallel planes. So any more doubts for anybody in the methodology? The thing is, just simply compare the x coefficient. Y and z coefficients are not at all required because we will have the parallel planes, same things will come. So if you take the x coefficients on both sides, you take 5, take the constant, using this you will get k and l values. There is no need to compare y coefficient and z coefficient, because similar things you are going to get. K plus l is equal to 5 always. So I want to take the other method. Can I? Right. So can I erase this problem completely? Fine. Let us take that x square plus 4y square plus 4z square and 4xy plus 8yz four zx. Then you have minus 18z plus 18. Minus 9x minus 18y minus 18z plus 18 equal to 0. Here also the question tag is similar. If it represents two parallel planes, find the distance between them. The same question tag we have taken here. Clear to all? Right. Now the method here is, we treat this as a quadratic equation. Because quadratic equation has the equal things, two roots. So if you feel that it is a quadratic equation, you can take it as x square plus x into 4y plus 4z minus 9, remaining all are nothing but the constant. So we take it as a quadratic equation in x. So now you are going to calculate the discriminant here, and x is nothing but applying the formula minus b plus or minus b square minus 4ac by 2a, the formula. So this is nothing but the value minus of 4y plus 4z minus 9 plus or minus square root of I think you know how to simplify that part. So I will write the final answer there. So you are going to get it as 2x equals to, taking 2 to the left hand side, you will have the part as minus of 4y plus 4z minus 9 plus or minus 3. So I will say that the entire square root part, all the terms will get cancelled. You will simply get a constant there. So if you simplify those things, you will get the equation as x plus 2y plus 2z minus 6. That is one plane equation, and the other one is x plus 2y plus 2z minus 3. That's it. So in this way we will determine the parallel planes, and obviously you can calculate the distance between them. So this is one model. I will say this model will be useful to you whenever you have the terms easy to compute and less number of terms in this kind of homogeneous path. If it is a big equation, the previous method is more convenient compared to this thing. Okay? Is the approach clear for everyone? We can also take quadratic in y also. What wrong is there? Quadratic in y, quadratic in z, anything. We are just treating it as a quadratic one. That's it. If you apply the previous procedure, it is x plus 2y plus 2z whole square plus some constant. That also very easy to apply here. So if you know the approach, you can make use of the better one, whatever it may be. Fine. So 3 by root 7 is the distance. I agree. Root 17. Or is the distance 1? I think the distance will be 1. Because modulus of minus 6 minus of minus 3 by square root of 1 square plus 2 square plus 2 square, it will be 1. That's it. So if the big equation contains less number of terms, so if you feel somewhat difficult to reduce that some part as square, so in that case this method will be very useful for us to deduct it. Right. So I want to take one more problem. Can I take that on this pair of planes? So it is given that a square plus b square plus c square minus 2ab minus 2bc minus 2ca is greater than 0. It is given if, and one equation given in the problem that a by y minus z plus b by z minus x plus c by x minus y equal to 0. The question tag of the problem is, we should prove this represents a pair of planes. That was the first one. And second, we have to show that the line of intersection makes equal angles with the coordinate axis. So this was the problem given to us. So he has given that this value is positive. Second, this is our given equation. We have to show that this given equation represents the pair of planes. And the second part is, since the pair of planes are intersecting, the intersecting line makes equal angles with the coordinate axis, say x, y, z. That was the objective of the question tag. Anyone needs any explanation over this, over the question? Please take a note of it. After noting, please tell. So the first thing is, I want to simplify the equation. So for doing necessary arrangement, so by observing the denominator, I want to multiply the whole equation with x minus y into y minus z into z minus x. So if I multiply the whole equation, it will come as a into z minus x into x minus y plus b into y minus z into x minus y plus c into y minus z into z minus x equal to 0. Now let us multiply the whole thing. I will leave it as a practice. You will get a big equation and I will take the terms as common. So you get it as ax square plus by square plus cz square. Then you have the part having this is the equation you got at the end. Please take a note of it. Now actually, in order to check whether this second degree homogeneous equation represents pair of planes or not, we need to apply the two conditions, that is the delta value, the determinant value must be equal to 0, and you have the conditions that f square is greater than or equal to bc, g square greater than or equal to ac, and h square is greater than or equal to ab. Now what happens, whenever an equation is given to us, generally we compare with the homogeneous equation written earlier. But here the equation itself contains the terms ABC. So in order to avoid the confusion, we will compare this given equation with capital AX square plus capital BY square plus capital CZ square plus 2HXY plus 2FYZ plus 2ZX equal to 0. So for notation convenience, without having confusion, we have taken the values like that. Okay. So on comparison, it is evident that capital A is equal to A, capital B is equal to B, capital C is equal to C. And if you consider the determinant where capital F is equal to half into these are the values. So if you want to evaluate the debt, this is the debt we take actually. So earlier we have taken small ABC in the formula. Here I have written the formula using capital ABC. Clear? Any doubts for anybody? Please let me know. Right. Now we are going to value of h is minus half into a plus b minus c, right? H is nothing but xy coefficient. It is not correct. So can anybody cross check the value of capital H there? Mine is correct or not? Right. Okay. Even though if you have a little doubt with the approach, why is the pair of parents equation taken as instead of ABCFGH? I didn't get you actually. You were saying that why I have used capital ABC here? Order. Order is anything you can take. There is no need of order. You can write in any order. See, whatever the order you write, you are simply writing the coefficients by comparing the equation, right? A stands for x square coefficient, B stands for y square coefficient, C stands for z square coefficient, H stands for xy coefficient, like that. Order is not at all important. We simply consider the respective coefficients. That's it. Is it clear now? We don't bother about the order. You can write in any order. Okay. Now what I am going to say is, if you substitute the values in the determinant, since we need to evaluate the debt, so if you have substituted the respective values in the determinant, you simply perform one row operation, that R1 tends to R1 plus R2 plus R3. That is, for the first row, you add second and third row values. So what happens? The first row will tend to 0, 0, 0. Second row and third row will remain as it is. You can simply check with your observation. So if you perform the operation R1 tends to R1 plus R2 plus R3, so after substituting the values in the determinant, you can easily verify that. Are we able to make the first row as 0 or not? Generally we do, which row will become 0, which row is to be added. So for the first row, if second and third rows are added, first row will become 0 completely. Second and third row will remain as it is. Since one row has become 0, determinant value is nothing but 0. Clear? Please check on that. So apart from writing on board, if you do on your own, it is very easy problem. So if you give consent, I will take the next part. Now see, you need to verify that debt equals to 0, and one more thing, you have 3 inequalities. Since we are using capital letters, capital H square is greater than or equal to capital AB, capital S square is greater than or equal to capital BC, capital G square is greater than or equal to capital AC. Right? Now, you can take any one of them. The thing is, let me say if you have taken F square and BC, in order to calculate the two values, you simply calculate F square minus BC. Now, what happens, if you calculate F square minus BC, the value is nothing but 1 by 4 of this part which is given in the problem. 1 by 4 of a square plus b square plus c square minus 2ab minus 2bc minus 2ca. As it is given in the problem that this part is greater than 0, so 1 by 4 of positive number is also greater than 0. So you can say f square minus bc greater than 0. Therefore, f square is greater than bc. Similarly, if you calculate the remaining two inequalities, they are also nothing but the same value you will get. H square minus ab, the same value you will get. G square minus ac, the same value you will get. Okay? Did you get the logic? Right. Now, you have verified the checking conditions. Since the verification process is completed, the given equation represents a pair of planes. So here you have done half part of the problem. The second part is given that we have to show the line of intersection makes equal angles with the coordinate axis. Did you get that? The second part of the problem I have written earlier. So you have represented that the given equation represents pair of planes. We have to show that you have a line of intersection. This line of intersection makes equal angles with coordinate axis. That is to be proved in the problem. Could you recollect? Right. Now, in the beginning of the session, I mentioned that for the line of intersection, you have the direction ratios, which are nothing but root of f square minus bc, root of g square minus ac, root of h square minus ab. This is the formula to calculate direction ratios for the line of intersection. Now what happened? All the three values are nothing but equal. Whatever the value you calculate, f square minus bc, g square minus ac, h square minus ab, whatever the value you calculate, the value is a fixed number. This is the number you get. 1 by 4 of this thing. So all the dr values are equal. Say x, x, x. If you cancel x, the drs are nothing but 1, 1, 1. So since the drs are equal, from that you can say that the dc's are also equal. Therefore, the line of intersection makes equal angles with the coordinate axis. That's all. So for the second part, we simply write that the drs are nothing but, we write the formula, the three values are equal. So drs are nothing but 1, 1, 1. Hence, the line of intersection makes equal angles with the coordinate axis. That is the conclusion. Clear? So that's all for today. I want to conclude our discussion here on planes. So on Monday, I want to take some little problems on planes. We will take it as a conclusion of planes chapter, and we will start straight lines on Monday itself. Right? If you want to say something, you can add now. That's all for today, and thanks for your good listening. Book you can follow Krishna series as well as Solid Geometry by Yash Chand, or Solid Geometry by Golden Series, anything you can follow. All the books have same content. You can follow BS Gravel also. Any one book is enough for you. One book is good enough. That's it. Yeah. Anything to say? So do you need any elaboration or any part of this today's session? Not WhatsApp group number, we are connected with only Telegram group. WhatsApp is not there. We are in the Telegram group. If you are a member, then it is okay. I will post it. The proofs what you have asked. As far as my knowledge is concerned, no proof is asked till now with regard to these formulas.